Hello everyone, my name is Ferron. I'm a PhD student in the INRIA Center of Bordeaux University. And today I will present you the work I've conducted with Embrassor, Pierre Dragicevic and Ivan Jensen on investigating the effects of augmented reality on message credibility when visualizing environmental impacts. More and more designers are using augmented reality to engage people with environmental information. Here's an example of Liester and colleagues, where a man is witnessing the sea level rise in Oslo in 2222. So here it's augmented reality with a smartphone, but we can use other hardware, like here an HoloLens 2. And here this man is looking at a pile of trash bags in his company's restaurant, and it represents the quantity of trash bags emitted during 1 week. So here, both visualization are using concrete visualization. A concrete visualization is a process of visually relating complex measures with familiar objects from the real world. Here is an example of Niemann and Rabet about greenhouse gas emission, where they are stacking the daily carbon emissions of New York City in Manhattan. And here a sphere represents 1 ton of CO2. And here is one of my former projects, where I represent the consequences of greenhouse gas emissions on a virtual mini-world, and here the sea level is rising across the years. So we got this what I call unconventional visualization, visualization that are more concrete with unconventional hardware, like in augmented reality with smartphone or headsets. And I upload that to more conventional visualization, like bar charts, line chart, pie charts on 2D on a sheet of paper on a desktop. So the first one is more concrete and the second type is more abstract. The first type is rather uncommon and we are more used to the second type, which is more common. And the point is to engage people with the first type of data, because the second type of visualization is probably more serious looking and maybe more boring. But by switching from the conventional visualization to the unconventional one, don't we run the risk to lose in credibility? Credibility is important and is defined in the communication science field by the believability of information. It rests largely on the trustworthiness and expertise of the information source or message. It's important in the context of environmental impacts because credibility has an impact on behavior, according to two social psychology theory, the elaboration likelihood model and a theory of planned behavior. So we could ask, what is the credibility of environmental information conveyed with unconventional visualization compared to conventional ones? To answer this question, we ran a study with 4 conditions across 2 factors. The first factor is the visual encoding. It's rather abstract or concrete. Second factor is the display modality. It's rather desktop or immersive. We got 2 main design of interests. AD for abstract desktop. It's a bar chart on a desktop. We got concrete immersive for concrete visualization in an immersive display with the augmented reality headsets. We got also CD for concrete desktop, concrete visualization on the desktop, and AI for abstract immersive, where we have an abstract bar chart on an immersive display. In the study, participants are looking to 3 types of data: carbon emissions, water consumption, and the PEF, the product environmental footprint, which is an aggregated environmental score across 16 sub-environmental items, including water consumptions and carbon emissions, and the bigger the PEF, the worse for the environment. Here we can see that for the abstract encoding, it's pretty straightforward, because on a bar chart, we are encoding the data through the length of the bar. But for concrete encodings, it's much more complicated, because we need to find a semantic link between the data and the representation. Here, for the water consumption, we decided to use some familiar objects containing water, like a glass of water, a bottle of water, a bucket of water, or a trough. For greenhouse gas emissions, since we are often communicating this data through its mass, we decided to use brass weights from 1 kilogram to 1 gram. Then for the PEF, it was rather complicated because the PEF is abstract by nature. It's a dimensionless indicator, So it's really difficult to find a concrete encoding for an abstract data. We decided to go with a unitized visualizations, where little cubes represent 0.00010 millipoints, and a big cube represents 0.01 millipoints, this is to say 100 little cubes. And we are displaying those cubes in glass containers, and it looks a bit like a disorganized bar chart. Our research questions are the following. First, how differently do participants judge the credibility of CI compared to AD? Then, how engaged do participants feel with CI compared to AD? And then, what is the difference in credibility and engagement across the visual encoding and the display modalities? We pre-registered our study on OSF. We got 32 participants. It was a within-subject study. It means that each participant experienced the 4 designs, and they got a different datasets per design. And the task was to follow an interactive data storytelling script. We measured several things: the perceived credibility, the perceived engagement, the perceived suitability, the perceived persuasive intent. All was quantitative data, and we also measured some qualitative feedback. Now I will show a bit of our results. So here I've reported the four designs which are here. Here is mean credibility score represented here. It was normalized between 0 and 1. We computed the data with the Bayesian framework. So here you can see that the black dot is the most likely effect size. The black bar is the 95% credible interval, and the gray density curve is the posterior distribution. So here we can see that for all of the designs, the score are high overall, and when we look a bit closer to our 2 main design of interest, we can see that there is no evidence for an effect because the black dot is centered on 0. So, and there is no evidence for an effect, and the effect is likely small at best because the black bar is really narrow around 0. Why so? It's probably because all the data were coming from a reputable source and the information was easy to understand. About engagement now. Here we can see clearly that CI is perceived as the most engaging visualization, and when we look closer between AD and CI, we can see that CI is also perceived as more engaging as AD. About research question 3 and 4, for credibility, there is no evidence for an effect. The most likely effect size is really close to 0, or the credible interval bar is crossing 0. But for engagement, we can see here that immersive is perceived as more engaging than desktop, concreteness is perceived as more engaging than abstractness, and then there is also an interaction between the 2 factors. Now I will explain a bit more about the limits of our results. So first, the credibility is impacted by various cognitive characteristics. It means that people are writing differently to credibility, and our participant sample was probably not really representative of the full population, so we need more study to replicate our results. And then also, our concrete visualizations are really specific to our design, and there is a lot of different possibilities, and we need more research to extend our results to different concrete visualization. A few takeaways to finish. First, there is no evidence for an effect on credibility, and the effect is at best small. It suggests that the information credibility about environmental impacts might not depend on visual encoding or display modality, at least for the design we tested. And then about engagement, CI can be substantially more engaging than other designs. Thank you for listening to me. I will be glad to answer your question if you want to reach me by email.